Hi, I'm Josh Stella, the co-founder and CEO of Fugue, and it's great to be here at DevOps Days Buffalo. Today I'm going to be doing a talk, let's get my slide up here, on locking down the security of IAM. So this is all about uh, IAM, which is really the network in the cloud. When you're configuring cloud native services, IAM really is the network. So we're going to do a few slides, mostly whiteboarding in this. And we've only got 25 minutes, so I better get a move on. Okay. The agenda today, I am going to go a little bit into why cloud security is so different than data center security. This is really important to understand, especially when it comes to things like IAM that are very cloud native, not just as a service, but conceptually and architecturally. We are going to do a deep dive into the security of IAM. That deep dive will, again, mainly be at a whiteboard today. And of course, we'll have some Q&A. All right. Every year, Fugue does a big survey of 300 organizations operating at scale in the cloud. And it is the State of Cloud Security Survey. This year, we partnered with our partners, Sonatype, to do this. And so these metrics you're seeing are directly from that survey. So when we asked, what are the most common cloud misconfigurations you're seeing, our respondents, the number one answer, although it's the number 4 row here, was identity and access management. Now, this is the first time, we've been doing this for years, this is the first time that has been number one. And I, for one, was really pleased to see that, because it means that the market is starting to really understand just how important IAM is, not just from a user perspective, right? Not just from a what are my IAM privileges, but particularly as it relates to services accessing each other and resources in the cloud. So 41% said this is a common misconfiguration. Right behind that, security group and firewall rules. Okay, that's a pretty obvious one. You know, ingress and egress ports. We all are always concerned about that. And then I want to point out the row 3 here, object storage access policies. So this talk is principally about IAM, but in reality, IAM is just one piece of the AWS policy stack that applies on a per transaction basis. And when we get into whiteboarding, I am going to drill in on what resource policies are, even though they're not specifically IAM, and why they matter so much. All right, a lot of cloud misconfigurations are not seen, and by cloud misconfigurations, what we mean are things hackers can use, ways that hackers actually attack your system. And I think for a lot of folks, there's a kind of question whether security policies are sort of security theater, or if they are in fact important to preventing hackers from actually stealing data or crypto mining in your cloud accounts, etc. And we try very hard at Fugue to understand what real world hackers are doing out there, and to build security policies into our product. And of course, I teach classes on this to tell you what these things are too, to build those policies into our product that are actually going to prevent hacks. So when we say misconfiguration, what we really mean are things that can be exploited successfully by hackers. Now, a lot of these things are kind of subtle and are not seen as problems by any of the big security frameworks. By those, I mean, and we, of course, support all these, dozens of them, but things like the various suite of CIS controls. NIST 800-53 might be the most thorough. CIS is probably the most up to date. It's still lagging the hackers, but more up to date than others. GDPR, HIPAA, etc. So a lot of security teams and organizations use these kinds of standards as a way to really judge whether they're secure and don't have misconfigurations. But a lot of those standards aren't really capturing what the hackers are doing, and so dangerous things are not seen as compliance violations. And I don't just mean like SOC 2 compliance. I mean compliance with security policy. They're not recognized as vulnerabilities. For example, well, actually, I'll get to. They're not recognized as vulnerabilities, and many of these things are only apparent in the full context of a cloud environment. And I'm going to give you an example of both of those two things combined, okay? So it is extraordinarily dangerous to have an EC2 instance or a container or some other compute infrastructure with an IAM role policy attachment to a policy that allows S3 list star when that compute entity, that compute resource, is deployed into a public-facing network directly or indirectly. Well, that's a long list of conditions, right? An S3 list star policy applied to a user account is not only not a big deal, it's necessary. Certainly, for even the AWS console to work properly, you need that, right? But to deploy that out into a running system, in that context, that's extremely dangerous. So as a result, and that's what I earlier was referring to about the kind of the subtlety of these things, hackers are not, our job as software architects, developers, I'm a CEO now, but my career has been spent in software architecture development. I was a principal solutions architect at AWS before founding Fugue, working primarily on national security kinds of environments. And when you're architecting systems and building systems, the goal tends to be, well, we'll cover all the turf from a security perspective. A hacker thinks quite differently. A hacker is just looking for that little crack, looking to wiggle through. So this makes it very challenging to prevent them, and you really need a lot of expertise to know how they're doing that. You have to be constantly watching them. And therefore, this stuff is really easy to overlook. Probably mostly because people aren't even aware that it's dangerous. One of my favorite G2 reviews of our product, which starts with "Fugue is going to hurt your feelings," and it's a positive review, right? That's our job, to hurt your feelings. It's our job to be paranoid about these things and make these things visible instead of easy to overlook. As a result of all this, though, this stuff is really common out there. We have a free version of the product. You can point it at your environment, and in 15 minutes, we'll tell you about it. Please do that. Just use it for free, and it's fine if you want to buy it later, but use it for free, and we will find stuff in your environment that is probably dangerous. And I'm just encouraging you to do that because I like beating hackers, right? So these things are therefore increasingly exploited in major breaches. I mean, they are almost always in a cloud breach, whether you're talking about the Imperva breach, the Uber breaches, the Capital One breach. These things are all due to misconfiguration of cloud resources in pretty subtle ways, okay? All right, let's talk a little bit about how hackers are actually operating these days. So in kind of the old days, the traditional attack pattern, I sometimes call it the Hollywood attack pattern. A target is selected, and then vulnerabilities are sought or created, right? Phishing attacks are an example of creating vulnerabilities. You can argue that they also exploit vulnerabilities, human vulnerabilities, but from a technical perspective, they are trying to create vulnerabilities. So when you see, for example, years back, Sony Motion Pictures made a movie that the North Koreans really, really did not like. And they went after Sony. They targeted Sony. They did phishing attacks. They got into all their networks. I mean, the news focused on the emails that they published to embarrass their executives, but they got into everything and did a ton of damage. So that's kind of the Hollywood attack, the traditional attack. That's not how most of these happen anymore. The way this generally happens now is the hackers are employing automation, like at scale, significant automation, to go look at anything connected to the internet and look for known vulnerabilities and misconfigurations. So if I'm a hacker and I don't know, I'm done with my session and I'm ready to go to bed because it's 6 o'clock in the morning, and I kick off a bunch of automation. When I wake up that evening and drink my coffee, I've got a list of vulnerable, misconfigured assets in the cloud that the automation has discovered. And then I'm going to go choose from that list who I want to attack. And that we know this is, in fact, how the Capital One breach came about. It was not targeting Capital One. It was a broad automation kind of trawling operation for vulnerabilities. And then, oh, look, there's a big bank on this list. That looks attractive. There were also, I think Ford Motor Company was on the list too, although it doesn't look like the hacker there actually breached and exfiltrated Ford's data. So John Breeden here is saying skilled or well-funded hacker groups are employing automation to discover and exploit misconfigured cloud assets within hours of their deployment. I was talking to a colleague of mine, not a colleague at Fugue, but a professional colleague at an event where we were both on a panel, and his whole focus is on tracking the activity of hackers. And what he told me then was, in their best estimate, the time you have between putting something on the internet, a TCP IP address that is in any way public facing, like an S3 bucket, for example, or a DNS record or an IP address, and at least one hacker having looked at it to probe for vulnerabilities is in the 5 to 7 minute range. So John here is being, from our perspective anyway, very optimistic about this. And if that makes you nervous, it should. This is a non-trivial problem, and the only response to this, because of the blast radius of cloud breaches, right? Cloud is actually the most secure computing environment humans have yet built. I feel very confident saying that. But if you configure it incorrectly, and IAM is a big part of this, the blast radius of the attacks that are possible are also much larger than data center attacks. So the data center, you're never going to get to the level of security that's possible on cloud if you really understand what you're doing. But the blast radius tends to be much smaller, by which I mean how much data gets stolen, how quickly. Right? It is entirely feasible, and this happened in some of the breaches I'm talking about, to collect all of the data in a very large database or object store or set of object stores. I think one of these breaches was 700 S3 buckets. That's why you don't want list turned on in runtime. In minutes, and there's no network traffic to interrogate. So really, really nasty blast radius. Oh, I bumped my microphone. I have to apologize for that. I'm sure it went clunk. All right, let's dig in a little. I've got about 10 minutes. So we're just going to do it at the whiteboard. Let's jump into some whiteboarding. Let me get my whiteboard up here. Okay, so what I'm trying to do in the few minutes I have left is give you a mental model, a way to think about the problem of IAM security. And this is critically important because the main thing we see people get wrong with IAM is frankly being scared by it, being intimidated by its complexity. So I want you to, if one thing you can take away from this, it is to understand how policy works in the cloud and where the critical decisions that you're going to make are really going to help or hurt your security posture. So let's start with, I'm going to talk about AWS. All the clouds are similar. We do the same stuff on Azure and on GCP, but I'm going to use AWS terminology. So in the AWS kind of world view, if you will, there are three main kinds of things. There are subsets of these, and there are special cases, but the first are what they call principles. Principles here are not like philosophical principles. They're actors. So I'll put myself here, Josh. Principles can also be things like EC2 instances or Lambda functions. But they're actors. If you remember back in the UML days, you would have actors in your diagrams, and that's how to think of principles. So the next thing are actions. And actions are the list of API verbs that are available on the cloud. So I picked on list buckets. I'll do list buckets. You might also have something like, for example, read object. Or things like create instance for EC2, right? And by the way, if you look these up, I'm probably getting the names slightly wrong. I don't have them memorized. There are thousands of these. Thousands of these. And this is where people get intimidated with IAM. Well, we'll come back to that. Let me talk about the third object type. The third object type is a resource. Resource. Yeah, I spelled it right. Good. And these are things that you have created in the cloud, the particular instance. So you might have an S3 bucket called foo, and you might have an EC2 instance called bar, and maybe you've got a Lambda called Baz, and I don't know, an RDS database. And what should we call this? We'll call it nil. Okay, so when you're defining policies, if you look at the policy definition language for AWS, they call it AWS policy language. It's really just a configuration file. You are granting the allowance for principals to perform actions on resources. All right, there is a default policy between all of these layers in AWS, and the other clouds are the same, and that is deny. So you've got these two kind of walls of denial, which means that any given principal, if I don't have permissions to do so, if I try to call an action, I'm going to get no from the AWS policy engine, right? I have to have an allowance to get through the denial. You can deny, you can allow. IAM policies, in the vast majority, if not all cases, are essentially poking holes through the deny walls to allow actors, for example, to perform actions on particular resources. Okay, so you'll see in a typical IAM policy there will be a section for the actions and a section for the resources. Very often, you will see star for the resources of a given resource type. So like all of S3. Now, we'll come back to this, but that may sound like a bad idea. And if the IAM policies were the only policies you had the ability to write, it would be a bad idea. But there are other policies that can help architect how this network of identity works. So what I mean by the network of identity really is when you start getting into things like running infrastructure, right? Where here we want this EC2 instance, which is of course also it's also a resource. It lives on both sides because when it's targeted, it's a resource, but when it's acting, it's a principal. Okay, so we might want this EC2 to be able to read objects in S3. I'm going to put some other S3 over here. Boy, I've run out of little programmerese. We'll just call this Z. So here you've got the ability, if you just have star on this policy, right, it's going to be able to get to any S3 buckets if it's S3 star as a resource. With resources, that might be fine. Depends on the resource type, and it depends on whether there can be resource policies. But you also see in IAM policies the allowance, the granting of permissions to perform actions. Far too often, I have seen star used. Maybe not all the actions on a service, but for example, EC2 has about 500 actions now. And you will see people writing policies like, I mean, just the read list is, I think, over 100. Well, it can be really troublesome to just pick out the exact ones you need. These things are complex, they have interdependencies, and there's a tendency to add just star to that, okay? Like EC2 read star. Well, there's dangerous stuff in EC2 read. So I would argue, this is usually an hour session, I have more time. I would argue that your actions should really never have stars in them, even for subsets like read, list, or write. There's two reasons for that. One is you don't really know what you're granting fully when you do that. You will never narrow it down, most likely. And you can use, you can design a system that is using actions that you think are safe, but they are in fact unsafe. And then finally, I guess there are three reasons. I guess finally, the AWS and the other cloud service providers add new actions over time, and they put them in those buckets. So you're inheriting whatever they decide to add without knowledge of it. And that's a bad idea. Okay, we're coming up on time. So I would limit, I would say here, no star. Over here, between actions and resources, I mentioned earlier something called a resource policy. So the way AWS handles policy, and again, they're all similar, is all the policies that are applied in a transaction that are relevant to a transaction are looked at as a whole. And if any of them deny access, the access is denied. Okay? So, for example, on S3 buckets, you can have what are called bucket policies. Bucket policies can limit the principals. They can limit them by IP address, by other kinds of identity, and so on. So if you have a big collection of S3 buckets and you don't want to write the names of the S3 buckets into the IAM policies that you're creating for your principals, you can wildcard those and then on a per bucket basis with those policies restrict who has access. I would always do resource policies on data stores for the simple reason that a common mistake I see getting made is people think, well, my IAM policies, I'll manage those to never do the bad thing. The problem with that is anyone who has the ability to create or modify an IAM policy can produce one that blows open your security model, and they can do it in like 30 seconds. So that's really not a great strategy. It's the old trust but verify thing, right? The IAM permissions over here on the principal are about what you're trusting, and you're going to verify over here at the resource layer. So I think that's kind of all we have time for today. If you're really interested in this topic and want to drill in deeper, I will be around for some questions. Our YouTube channel has a bunch of videos on how to secure cloud, and including deeper stuff on IAM. So great to be here. Thanks for your time. This is my personal email address. You can visit us on the web at fugue.co. We've got a ton of content that will both the videos I mentioned, classes I mentioned, but also blog posts, etc., documentation there. So thanks again. Great to be here.